Hello and welcome to our overview. Basically, it has three main components: the directory, the bucket, and the client. The directory routes as a main API public endpoint to our system, and it routes as a respectful requests to the buckets. How does it determine where the entry goes? It basically computes the hash and modulus the bucket count, which is a parameter we can configure. We can increase the number of buckets, for example, and this function will still forward to bucket. Forward to bucket is just a helper. It basically forwards the get, put, and delete requests to the respectful bucket. And we can see here that our public API is just put. So you basically can put, so create or edit the existing entry. You can get the entry, you can delete the entry, and you can check the health of the directory, which will basically return you the bucket count directory knows about. Well, now let's see the bucket. Bucket is basically Directory is a fast API app. Bucket is also a fast API app, so they communicate with HTTP, with REST between each other. Basically, Bucket, it has the dictionary of these key value pairs in its memory, but it also stores this dictionary to the storage with the saved data. So it basically has some file in its storage, and every time we do some destructive action like put, like delete, so whenever the entry is updated, created, or deleted, we update our dictionary, local dictionary in memory, and also we update our storage. And if, for example, the bucket code was restarted for some reason, if it turned down, it will basically load the data from the storage file first upon its turn up. Then the third component is the client. Basically, directory is a Kubernetes pod, and each bucket is a Kubernetes pod. So those things are separate components. The client is not a Kubernetes pod. It's just for local testing. So it's not on Kubernetes, but it's a separate Python file as well. And overall, it basically loads the data set from the data. It uses the first column as a key and the rest columns as one big value to have those nice key value pairs. And the workflow is the following. So basically, as requested, it inserts the data, it reads from multiple buckets, and it deletes the entries and checks that everything works correctly and logs to this test report log file. Here, for example, we limited number of records to like 1,000 because we don't have infinite memory, and it nicely inserted all 1,000 records. And the interesting thing is bucket distribution here, because we can see it's quite even. For each bucket, we have around 200 entries, and we have in total 5 buckets. Data access also succeeded, so we read it from different buckets, and we also tried some deletion. So I say we, but it was basically I. And it basically gives you some test summary and where the log file is located. Regarding the decisions, using this CAP theorem, my cloud storage system, it prioritizes partition tolerance and consistency, but it does not prioritize availability, because here, for example, you can see that if the bucket goes down, then we have this exception, bucket unavailable, until it becomes available again. With event-driven architecture, this problem can be solved, because we can have some Kafka topic, and the bucket, so basically the consumer will consume this message as soon as it becomes available. Also, some more interesting decision can be found in this Kubernetes. So bucket is basically a stateful set. It's a perfect candidate for a stateful set, because we need to have some number of replicas, for example, 5, and all of which should have a durable volume storage. And also